Welcome to this CPD video on top lighting solutions by the Rooflight Company. We were founded in 1993 by an architect called Peter King. He developed the original conservation roof light. Made from a mild steel, this ensures the longevity of the products which are still in circulation today. He has now returned to architecture but remains heavily involved in the design of our products. Since inception, we have expanded our pitched roof light range with the contemporary Neo, our flat roof range, and we have a bespoke department for custom-made roof lights. The objective of this CPD is to understand how different roof lights complement building designs and how to overcome technical challenges. Let's start by looking at the importance of the placement and size of a roof light.
As architects, we explore and experiment with light, and a roof window is a way of admitting light. The human imagination responds to differences in light, not uniformities of light. So imagine you have a roof space or a workspace. If you vary light across it, it's a better thing than uniform light. So that's why we make such a vast range of roof windows. It's just to encourage people to use light in a painterly way. You can use roof windows to provide that lovely white light, the vertical white light that we get from the sky, the cloudy sky in this country. You can use roof windows as an inverse sundial. Roof windows don't have to be rectangular, and they don't have to be small, or they don't have to be large. It is possible to pull roof windows around like an elastic band, and we can make whatever an architect pulls their elastic band into: trapezoidal, triangular, long and thin, vertical, horizontal, opening, non-opening, grouped, star-shaped. It can be done. The original range of roof windows was the conservation roof light, which is a replica of a Victorian cast iron roof window with a glazing bar. The first conservation roof windows were put in approximately 20 years ago. They're still there today. Longevity is important to us. It is sheet steel, galvanized, and it has a very durable paint finish. We use external hinge posts, which were a characteristic of the original. We use glazing clips at the sill of the roof window, which look like the original. It has remained a very low profile window. It is approximately 4 inches or 100 millimeters, just slightly more than 100 millimeters high off the base plate, which means that for most building materials it is flush, and that looks quite different from other roof windows on the market today. It's probably the lowest profile and simplest looking roof window on the market. Light from above has a different quality from light from the side. In England, it's white light. Like today, it's sort of white light from above, but you do get that lovely shaft of directional light on certain days. Roof lights can sometimes provide a lighting solution. It is possible for roof windows to provide virtually the only solution possible by just pointing the glass up to the sky. If you put an arrow slit of a roof window quite near a wall, you'll be quite surprised by the effects that you get. They're quite lovely effects. The roof windows are... If we can help an architect by devising an extremely thin, long roof window, or a very large roof window, so that you get lots and lots of white light, that's what we want to do. We actually want to help architects paint with light.
Flat Roof Extension, Oxfordshire. This image is a real-life example of how Peter King has simulated where light and shadows will fall within the building throughout the day. The trio of roof lights to the left of the roof has been purposely located here so that morning to noon light will play off the side wall interiors. One of the roof lights was also fitted with a motor to provide ventilation. The central roof light is located over the lounge area and acts as an inverted sundial, with the sun moving around the lounge as the day progresses, indicating the passing of time. This section looks at the conservation roof light in a variety of contexts. The glazing bar and silicon finish means it fits well into historical buildings within conservation areas, but with its flush finish and fine lines can also work well in a contemporary environment. So what is a conservation roof light? After a lot of research and listening to experts within the field of conservation, we compiled a list of what makes a conservation roof light. Modern conservation roof lights can combine these features with modern materials and manufacturing methods. For example, using a powder-coated mild steel imitates the cast iron design. A silicon finish around a slim frame can really replicate that of the traditional putty. A stepped edge glazing can imitate the single glazed appearance, and a flush finish with the roofline replicates the original design. This is an example of a traditional looking roof light. With a flush finish and clean lines, they are unobtrusive and do justice to the heritage of the building. When building products are required to work within planning constraints, this can require a considered approach. There can also be a number of restrictions in terms of product selection, as many planners require items to be replaced with like-for-like alternatives, both size and design-wise. The refurbishment of Somerset House in London required a level of careful consideration. This was done over 2 phases, with the large flat roof window shown on the right-hand picture being placed above the map rooms. The planners stipulated that exact copies of the original bespoke wooden roof window, dating back from the turn of the century, were required for the Somerset House building. Maintenance to the roof was a major problem, and as a result, a low-maintenance product was essential, hence the decision to specify steel roof lights with a protective coating. The range of existing sizes was vast, and the different shapes and sizes required an extensive site survey, whereby the appropriate design and dimensions were drawn up and proposed to the project architect. The paint finish was specified as grey-olive finish to match the original Cumberland slate tiles, of which most were retained during the refurbishment, shown on the left image. Due to the nature of this project, a standard design roof window would not have been suitable, as the apertures had already been formed. For Clapham Loft, Twistin Architecture wanted a roof window that would replicate their exterior Victorian building and complement the internal exposed metal. They were also concerned about the internal head height within the loft. They therefore used a conservation roof light to complement the aesthetics of the building that is also top-hinged to allow for the restricted head height. The staircase and roof windows form a family of exposed coated black steel, which results in a contemporary industrial feel whilst introducing top light and ventilation. Thought to have been built in 1824, Reed's Mill was built at a time when grinding wheat was so profitable it was not just the great estates but also the church that controlled milling. Locally listed, it remained as a ruin in the Fagg family for nearly 100 years, when, seeing the potential in its refurbishment, the family recently set about converting the derelict shell into a home, with a new-build barn and glass conservatory attached to the refurbished mill building. For this project, architect David Bench wanted to replicate the style of windows that would have been used back when the mill was working. David works mostly with listed buildings in the Canterbury area. This project in a conservation area had to comply with strict planning and conservation regulations. Although roof lights were agreed, it was under the stipulation that they would sit completely flush in the roof. 8 conservation roof windows were used, plus 4 side-hinged egress and access conservation roof lights to allow for B1 means of escape. This project was a renovation of an old derelict barn. To provide light to the spaces below, 14 roof lights measuring 2.6 by 1.3 meters with a mixture of openings were utilized. All are linked vertically to provide the maximum natural light below. For this project, the client wanted to utilize a dormer window. However, planners stipulated it must be a flush-fitting conservation-style roof window. The roof at the rear of the dwelling was opened up to incorporate a large, flush, low-profile conservation roof window with an overall width of 3.6 meters and an overall length of 3 meters, enabling the occupants to take full advantage of the views in its setting. To overcome the head height issue, the attic floor was removed and alterations to the floor plate were made to create 2 usable floors within the property, essentially creating a mezzanine floor level. This drawing shows 2 base plates which have been linked together to allow for the structural supports that were needed and stipulated by the structural engineers for this large expanse of glazing. A more contemporary roof window should also sit flush with the roofline to ensure it does not dominate the roof. Here are several options that exist to enhance your contemporary roof light. A key feature of the design was for the building to be super insulated, as it was imperative that the roof window did not compromise the thermal efficiency of the building. The client initially requested triple glazing. The planners, however, stipulated that the roof window design ensured a low-profile finish which sat flush within the roofline. Triple glazing could have potentially resulted in the roof window design protruding outside of the roofline, as well as increasing the need for artificial lighting within the property. As a result, therefore, one of the challenges faced included sourcing a glazing specification which could achieve the thermal performance of triple glazing, ensuring the depth of the unit would allow for a flush installation. The brief also combined the client's vision to replicate the style of the artist James Turrell, who focuses his primary works on light and space. In the 1970s, Turrell began his series of sky spaces, which were enclosed spaces open to the sky through an aperture in the roof. Inside, the viewers sit on benches along the edge to view the sky through the opening in the roof. The traditional roof windows, generally approved by planners incorporating a glazing bar, would not have conformed to the client's aesthetic requirements, providing another challenge for the design team. In response to the brief, a frameless roof window was specified which satisfied the stringent planning requirements by sitting flush with the roofline, therefore retaining an aesthetically pleasing product in context. The roof windows were carefully positioned above the bath, shower and bed in the top floor of the building. The roof window, in particular, with its frameless appearance, complemented the idea of creating the sky space works of Turrell. To ensure a focal point for the skylights, the reveals were splayed at an angle to gain additional light into the dwelling. To respond to the thermally efficient aspect of the brief, double glazing utilizing Saint-Gobain's glass was specified. It has a self-cleaning outer with a Planitherm 1 inner, and it achieves a center pane U value of 1. As demonstrated in the external image of the installed roof lights, the design also satisfied the flush profile which had been stipulated by the planners. 28 roof windows were specified for these Grade 2 listed holiday lets in 2 sizes. Charlie and the owner wanted to ensure that these would not sit proud of the zinc roof. Many of these roof lights also comply to B1 as means of escape from some of the bedrooms. This project had a mixture of sill motors and manual opening as well as blinds. This residential project was designed to reflect the local agricultural architecture, specifically the style of local barns. This was created as a single story of stonework with a steep pitched roof atop, giving the feel of a single-story barn and a reduced sense of scale. Installed into a pitched roof of 58 degrees, it was important for the roof lights to sit flush with the roofline to provide a sleek finish. 11 roof lights were specified for this scheme, each with a sleek handle for easy opening along with 7 blackout blinds. When architect Gareth Pywell, founder of POW Architects, bought this Victorian semi-detached house in central London, he couldn't wait to start increasing the living space in the top of the property. As an area usually defined as low-eave storage space, the design exceeds that usually defined as a loft extension. The new area with a raised roof has been designed to flood both the new extension as well as the main living area below with natural light. At planning, this award-winning project was approved by the planning committee and work began on transforming this Victorian building into something that would have a striking sculptural roofline. 3 roof windows were specified for the scheme. The white internal linings became a continuation of the new contemporary decor. The concealed motorized openings allowed for ventilation to the extension space below. Externally, the roof windows were installed flush with the slate roof, echoing the simplicity of the interior. Zinc cladding covers the external walls to become a feature which looks as though the new roof is running down into the existing external walls. Byrne House has been recognised by the Federation of Master Builders with a regional award, as well as being an AJ Retrofit Award finalist. Rob McGinnes of Hive Architects designed this new extension for his own home in Knutsford. The aim of the extension was to celebrate and innovate with timber, texture and light. Both roof windows have been orientated south to increase solar gains and light levels. Since completion, Woodroom has been awarded with the Manchester Architect Awards Best Small Project. Woodroom was also shortlisted for the Structural Timber Awards Architect of the Year and Private Housing Project of the Year. The Clay Field project focused on the development of 26 affordable dwellings. The aim of the project was to create a contemporary design with low energy use, incorporating innovative local materials such as hempcrete, lime mixed with the hemp associated with the region's agriculture. The houses were laid out to exploit the area's fabled landscape and low-angled winter sun, and are all south-facing. The challenge faced when specifying the roof windows was to incorporate a product which met with the building requirements for temporary and affordable living, sympathetically meshing with the colour of the vertical windows. There was also a requirement for the roof window design to be large-span windows positioned on the southern side of the building, enabling the sun to heat the building through the large expanse of glazing. The project achieved a 60% reduction of in-use and embodied carbon emissions compared to almost any other multi-unit residential project. The roof windows were RAL coated in a pale green to match the windows and specifically manufactured to accommodate the roof pitch, and complemented the aim for the contemporary design with the frameless appearance, and are designed to maximize passive solar gain and control ventilation. The heating and hot water is fueled with locally sourced wood chip biomass, emitting significantly less CO2 than localized gas boilers. Rather than employing solar panels, the houses are designed to work as solar collectors and provide most heat and ventilation passively. The project was shortlisted in 2009 for an RICS Award for Sustainability and also received an RIBA Award, a testament to the quality achieved across the whole of the build. There are many ways to ensure a flush finish. Demonstrated here are two installation methods depending on the build-up of the roof: between the rafter and on the rafter. A between the rafter installation would mean a flashing kit could not be used and just a code 4 lead to ensure a watertight seal. Which option is most suitable would depend on the roof build-up. Our next theme looks at roof lights and the importance of using the correct product designed for the roof type. This is a question that we are often asked, and the simple answer to this is no. The design of a pitched roof light is entirely different to that of a flat. Most importantly, it will not perform adequately, but also the aesthetics are very different. Pitched roof lights should be designed to sit flush and be unobtrusive. Besides this, there are a wide range of both standard pitched and flat roof lights to suit your project. Typically, in a pitched roof scenario, a roof window will lie directly in the path of deluging water being delivered to the head of the window from above. This places stress on two aspects: 1, the integrity of the frame joints, and 2, the integrity of the abutment details. Roof lights for flat roofs are designed to be installed on upstands, typically made of timber. These upstands lift the roof light away from the roof surface by approximately 150 mm. Other than the rainwater that falls directly onto them, water never accumulates on the roof light frame. This means that there is less emphasis on the ability of the roof light frame joints to withstand a deluge of water. Roof windows designed specifically for installation into pitched roofs therefore require carefully considered jointing methods. In addition, the abutment details, perimeter frame details, and flashing kits must be specifically designed to withstand ingress of water when installed on a pitched roof. Let's look at a bespoke example. Courtyard House, Shepherd's Bush.
When you're inside, you look up and you almost have the impression that there's nothing there at all. Like a James Turrell, or like the opening in the Pantheon, you know, just an oculus. Light brings space to life, you know. Without light, you know, what's the point of space? 4 years ago, I spotted this site. It was at auction, surrounded completely by Victorian buildings, and I realized that with all the adjacent buildings we had to build something that would be quite low in profile because it sort of interfered with adjacent established rights to light. And the idea of these pavilions with the pyramidal roofs came up. The house is made up out of 6 pods, and then together the pods define the courtyard, and I didn't want the windows facing the courtyard to be too large, so it became clear that we needed our source of light from above. We got working with the Rooflight Company quite early on. I had been familiar with the Neo Rooflight. I worked with Peter King for the development of that product, and we showed him a really early model of the scheme. That informed the design because he spoke to us about the maximum dimensions, for instance. We then changed the design so that we would get a really nice big opening within the parameters that sort of make sense over each pavilion. The geometry of the building is incredibly complicated. Hardly anything is rectangular. We started having these trapezoid shapes by intersecting, sort of slicing off the top of the pyramids at an angle, and the pyramids themselves already not rectangular. So you had all these different trapezoid shapes. The Rooflight Company had all the 3D modeling of their system, and they could then quickly develop the trapezoid versions so that we had fairly good visualizations of what things would look like. Yeah, it's a very complicated project because no two roof lights were the same, and we knew we wanted opening roof lights. That was one of the criteria. We knew it was going to be difficult to reach them, so it made sense to have an automated system to lift up the roof lights, and I knew that the Rooflight Company had worked that system out completely. They knew exactly which motor to put in with which weight roof light. And then on the outside we needed to get the frames to sit on top of the standing seam roof, and so the surround of the frames had to match the color of the standing seam roof, and then it just had to sit on like a sort of slice of red steel. That's what we wanted from in the side elevation. It was terribly exciting when they finally came in and they were lifted in, and we got onto the adjacent roof and looked down, and it was a major milestone in the development of the project when that happened. The thing about the natural light is, of course, that the top light is that it changes all the time. It changes the moods inside the house. It's a great source of light, and you can follow the course of the day as the light moves around. So you're very in tune with what's happening, what nature's doing around you. So it's almost a spiritual quality. Throughout this project there was a sort of excitement and buzz about making it happen, and I think everybody shared that, and the roof lights were a really important part of bringing the whole project to life.
Historically, the only choice for a Ridgelight was to place roof lights either side of the ridge beam. This is no longer the case. A fully self-supporting roof light will reduce the distance between the glass, omitting the need for a ridge beam. They are fully assembled, so easy to install, and give a beautiful frameless appearance internally and externally. Beccles Health Centre required an extension to improve consulting space and patient services. The plot for the extension was a corner design, and therefore to maximise the available space, the building was designed to fit exactly to the footprint, which is a triangle. The extension features vertical windows. However, as a single-storey building, there was also the opportunity to maximise natural light and allow natural ventilation through the flat roof. Rather than specify a standard-shaped skylight, LSI architects wanted to create a design which complemented the overall building shape and allowed a focal point for patients in the waiting room. As a result, a number of bespoke triangular roof lights were provided with electric actuation. As the shape and design of the product was of paramount importance here, inquiry drawings were submitted at a consultation stage to ensure continuity, clearly identifying the clear structural opening sizes of the units. A 4.5 metre roof window was used for this project in London. This is placed above the stairwell of this 3-storey residential property, consisting of 4 linked triangular base plates to create this unique design. 12 of the casements were also fitted with electrical actuation whilst connected to the building's BMS heat and rain sensors. This project focused on the refurbishment of a semi-detached property in the London borough of Richmond. Simon Merony wanted to create a roof featuring photovoltaic panels to provide renewable energy to the home alongside a roof light to fill the attic space below with natural light and ventilation. Aesthetics was a key part of the brief, and the architect did not want to compromise on the appearance of the building externally. Therefore, it was essential to specify a roof light that was both elegant and seamlessly blended into the roof design by mirroring the dimensions of the photovoltaic panels. Having considered the brief, the design team then produced a design proposal for a frameless solar roof light measuring 1.7 meters wide and 1 meter high to perfectly complement the design scheme and the PV panels in dimension. The roof light was then installed on the roof structure, incorporating an individually designed flashing detail to coordinate with the PV panels. The roof light also featured a concealed motor to allow for electric actuation, ensuring the minimal frameless appearance was reflected from the outside in. Often, larger spans of roof windows are required for a project, and there are varying solutions depending on the project need and budget. There are various linking options to create larger spans of glass. Here are 3 examples. A linking bar to link the roof lights. This removes the need for delicate LED flashings. There is also the chance to link the roof lights together, or a single base plate will give the appearance of one long roof light run. These 3 linking options can be combined and applied to historical buildings. You can see the differences in aesthetics here. You can also use these 3 linking options for a contemporary roof light. However, as the framework is slightly different, you will notice that the distance between the viewables and casements is slightly larger. We cannot use a linking bar for a flat roof window due to the curb upstand. However, these can be installed side by side. A contemporary flat roof light can be installed side by side with much smaller gaps between them than a historical style, as they do not require the large skirt curb. This side-by-side detail explains how to install side-by-side. This former Victorian coach house required maximum light to a hall and open stairwell whilst taking account of original oak beams. Award-winning architect Peter Williams specified 10 roof lights with linking bars. These provided ventilation and the required light whilst conforming with strict planning regulations and did not in any way detract from the external appearance of the building. Howl Associates were appointed by Worcestershire County Council to design the new St George's Primary School in Kidderminster. Flat roof lights were selected to create a distinctive top-lit arrival space within the school that provides a clear orientating element that links the hall with other teaching spaces. Phil Howl of Howl Associates explains, the roof lights flood the space with natural light and create a strong visual rhythm that leads the eye through to the contemporary external cloister beyond. 5 runs of roof lights were specified by the architect, with each run of roof lights being made up of 4 casements on 2 base plates. The success of the overall design was recognised, with Howl Associates receiving an RIBA West Midlands Architecture Award for this project in 2013. Maximising light ingress. On occasion, clients seek to replicate an idea they have seen on a previous building. This was the case for this project in Oxfordshire, where the client wanted to replicate the design of a building which had previously been viewed whilst on holiday in Europe, to feature a continuous run of roof lights along the roof, ensuring as much natural light as possible would fill the space within their summer house. They have utilised a standard run of contemporary roof lights consisting of 3 casements on 1 base plate, each with electric actuation and motorised blinds. Retaining heritage features. When restoring heritage buildings, sympathetically designed building products are key, as is attention to detail to ensure the result is a faithful reproduction of the original building. The Derby Roundhouse project focused on the restoration and transformation of the Grade II listed building, first built in 1839, into a modern college facility. The site was listed on the Buildings at Risk register and had been allowed to decay for a number of years. Some of the buildings had suffered up to 20 years of neglect. As a result, the scale of the project was large, with a contract duration of 22 months. The challenge from a design point of view was to replicate the original roundhouse top lighting, ensuring the heritage features remained, yet the units performed to modern standards, including electric actuation to allow natural ventilation to the vast public space beneath. The most challenging aspect was ensuring a continuous run of roof windows measuring 2.3 meters long to fit what is essentially a pitched circle. meaning that standard rectangular shapes were not suitable. The technical design team devised 48 trapezoidal-shaped roof windows which could link together around the roof hip, consisting of 16 individually designed facets, each with 3 individually sized casements, resulting in a direct replica of the original glazing. The system to link the facets was made up of structural linking bars, which facilitate the base plates to link together, incorporating structural supports and removing the requirement for a run of tiles between, as per the drawing illustrated on screen. 2 50mm rafters support the units structurally, whilst externally the 10mm linking bar, combined with a silicon bead between the LED flashing and bar itself, seal the roof windows, thus allowing the building to be weathertight. In addition to the roundhouse element of the project, a further 64 linked roof windows were provided to the engine sheds, combining a detail the same as the casement design for the roundhouse, which results in a 12mm gap between the external casements, giving the appearance of a continual run of glazing. Aesthetically, this was the favoured design method, as it enabled the building to be restored exactly as it was originally, with products which performed to the requirements set by the college. We have looked at the aesthetics of many roof lights, but we also conform to modern standards. Here are some examples, starting with noise reduction. It is widely accepted that a typical background noise of 70 to 80 decibels caused by outside traffic can create disturbance and stress over a continued period of time. Although there are no defined building regulations pertaining specifically to roof lights, Section 8 within Part E of the Building Regulations seek to include school buildings within its framework, identifying noise pollution as a detriment in affecting a child's ability to learn. As a result, typically, schools will aim to restrict noise levels below 50 decibels during lesson time and below 40 decibels during examinations or periods of quiet study. These are the different areas within the Brentwood School project. The flat roof window on the left was installed in many areas of the school, including on some of their sedum roofs. In the middle they have a frameless window, but that is 3 casements placed on the one large base plate, and on the right they used a conservation roof window, but in this trapezoidal design. Additional to the performance criteria, it was important to distinguish the new part of the building as modern by incorporating simple edges, windows, roof windows and roof lights. It was also essential for the design of the roof windows to emphasize the flush fitting against the patterned brickwork of the building from an aesthetic point of view. The challenge for the team of designers was to combine the requirement for flush-fitting low-profile roof windows complementing the building design whilst including a specification of glazing which met the requirement for sound reduction and thermal efficiency. The picture left shows the internal image of the linked frameless roof window that was installed in the walkway building. The detailed drawings on the right were supplied. They show the framework and corner brackets required for the installation on site. In addition to this, a technical support team were made available to advise on the installation. When seeking to include a noise reduction specification in a roof light package, the following specifications can be offered depending on the rating required. The upgrade option is specific to bespoke fixed shut casements. However, if ventilation is required, the design team can complete feasibility calculations to determine whether the casement can be electrically operated. This was the case with a motel project in Edinburgh, which was completed in 2012, whereby a specification was provided which achieved a 46 decibel sound reduction with a test certificate. This specification was teamed with chain actuators to meet the brief set by Morgan McDonnell Architecture for the option of motorized opening. This section of the presentation will focus on achieving access and egress through roof lights and roof windows. Projected government demographic studies indicated a significant shortfall of primary school places across the UK in 2011. This was particularly relevant across the London Borough of Merton. Therefore, Haverstock Associates were briefed to design a 1,250 square metre extension of the Victorian Wimbledon Chase School building in order to achieve additional space for a total of 630 pupils. Within the context of the extension, the architect stipulated a requirement for automated, high-level glazing from a large span roof window to achieve natural light and cross-ventilation. Crucially, though, the roof window was required to incorporate discrete access to the 30-degree roof to allow maintenance staff easy access to the roof line. By linking the roof windows together onto one base plate, a large span was achieved. The unit included a number of motorized casements to ensure natural ventilation. Specifically, one casement included a gas strut system which enabled the casement to open to 65 degrees, thus allowing access. The detail provided by the design team demonstrates the clear distance achieved between viewables and the individual clear viewable width of the casements. Each casement, including the casement designed for access, are an exact replica of each other in terms of size, ensuring continuity from the outside in. Specific gas strut calculations are undertaken by the design team, incorporating the roof pitch and casement weight to determine the gas strut force required to support the casement in an open position. The glazing spec seen here has also been tested to TN 6667 Class 2 for safety and fragility and can be applied to any flat roof lights that fall between the standard size parameters. A demo unit was manufactured incorporating the impact glass specification, which was then sent to the BRE for testing to TN 67, offering safety and fragility of glazed roofing. The test sequence uses a combination of hard and soft body impacts and a static load test on the glazing system after fracture of the glass. A minimum of 3 test panes, or units, which are representative of those to be used in the glazed roof, should be tested within the roof assembly. Testing is also carried out on a pitch equivalent to the environment in which the roof windows will be situated. The soft body test was developed to simulate the effect of a person falling on a roof surface from a standing position, and the hard body test is intended to simulate the effect of impacts that might arise from tools and equipment being dropped onto the roof. Finally, the static load test is carried out after the impact testing has been completed. If the outer pane of glass has not broken during the course of the impact testing, all glass is broken prior to the static load test, which is intended to represent the weight of a person, 90 kilograms, who may fall onto the glass and become injured. The testing is carried out over a period of 30 minutes, which is considered to be the time the glass should maintain load-bearing capacity in order to allow assistance to arrive to rescue the injured person. 2 of the 10 roof windows were specified with a switchable glass, which, when placed under the effect of an electric current, switches from translucent to transparent with no alteration of light transmission. These roof windows were installed in the master suite of the building. Matching vertical fenestration as a design brief requires a considered approach, particularly when using 2 separate suppliers. This was the case for the granary, the refurbishment of a 19th century bronze-clad building which had been derelict and unoccupied for some considerable time and was in urgent need of restoration. The aim was to bridge the gap between the old and the new, as well as providing the maximum amount of natural light to both the granary building and the new extension. Pollard Thomas Edwards Architects chose to adopt a contemporary approach to the extension in particular. The challenge faced was for the vertical windows and roof lights to mirror the design of each other to ensure symmetry of the building, incorporating a low G value to the glass specification. The design team were able to mirror the aesthetics of the new aspect of the building and provide symmetry to complement the vertical windows in the project by designing a frameless roof window. The bespoke design was the favoured approach for this project, as the offset glazing bars featured in the design ensured symmetry with the vertical windows, whereas a central glazing bar or a roof window with no glazing bar could have compromised on the overall aesthetic quality of the build. This design was able to maintain a profile close to the plane of the roof, achieving a contemporary appearance. The right-hand side of the casement is designed to open to allow for natural ventilation. Motorized linked skylights were also specified on the refurbishment element of the project to maximize natural light. The G value achieved with the glass specification was less than 0.3, maximizing the overall solar transmittance of the glazing. A lower G value represents less solar gain, meaning the building can be exposed to natural light with less risk of exposure to increased temperatures within the building during periods of sun exposure. Part Q is now a large consideration for many projects, and there are a variety of solutions to meet this, as well as added security and secured by design. In order to meet the brief with regard to the skylights and ensure that natural ventilation was incorporated whilst not compromising on the security features, particularly given the single-storey design, 17 openable mono-pitch roof windows were provided. 2 linked together to create a large expanse of light. One roof window in particular is a large array spanning 12 metres wide and 1 metre long. The roof windows meet the brief with regard to security by incorporating tamper-proof hinges without having to have bars across the glazing which could have compromised aesthetics and light. They are also connected to the building management system with rain sensors, ensuring the skylights automatically close in adverse weather conditions. The diagram demonstrates the functionality of the tamper-proof hinges and the components that would be required in order to remove the casements from the base plates to gain access into the building. The security nut has a 30-degree angle for greater resistance against removal by conventional tools, and the hex portion of the shear nut shears away when correct torque is achieved, leaving a tamper-proof dome. The components are manufactured from hardened steel with high resistance to conventional drill, saw and chisel attack. This approach can be favoured by specifiers as it allows for an increased level of security with minimal impact on the overall aesthetics. Some projects call for high security levels, and as a result, appropriate products which conform to certain accreditation will be required. The Keep, which is a new state-of-the-art historical resource centre in Brighton, called for a high level of specification due to the historical documentation that was to be stored within the building. The building was designed to house over 6 miles of archives and historical resources for East Sussex and Brighton and Hove dating back over 900 years. The records document the lives of individuals, places and events from across the community, and the building is open to anyone who wants to use the public search rooms and facilities. To accommodate the brief, 11 1.2 square metre roof lights were provided and installed into a concrete curb upstand, certifying them to Loss Prevention Standard 1175-7 Level 3. The P6B outer layer of the glazing is also tested to BSEN 356 and gives a U value of 1.35. The roof light specification also includes 4 optional GRP-coated stainless steel intruder security bars which always run lengthways in order for any condensation buildup to run down the bars and through the base plate profile, finally flowing through the small U-channel grooves at the bottom of the casement. Thank you for watching this CPD video about the solutions which are available from the Rooflight Company to meet a variety of briefs and challenges. We now can provide BIM objects in Revit format across all of our standard range roof windows. This includes the Neo, Plateau and Conservation. To find the Revit models, please visit our website and go to the Drawings and Download section. This will then give you access to the models and also our guides to provide useful tips for getting started. Alternatively, we can still provide our DWG installation drawings. We've shown you a number of solutions which have been provided for past projects. However, the Rooflight Company excel in new ideas and tailoring our designs to suit most briefs. We hope you will have the opportunity to challenge us in the future to provide a solution designed specifically for your projects. Further information can be accessed directly via our website, therooflightcompany.co.uk, and also our technical sales team, who can be contacted on 01993 833 108, or you can email victoria.tarrant@therooflightcompany.co.uk.